In this video, we're going to look at a little problem that is mostly about the Nyquist sampling theorem. So it reads, according to this Wikipedia page, mice hear sound in a range of 900 hertz to 79 kilohertz, as opposed to humans whose range is 16 to 20 kilohertz. Adapt the transmission rate of CDDA, digital audio CDs, not that people I still occasionally listen to them, but most people don't. But adapt those specifications to mice and sort of explain why. So we need to know about the CD specifications. We need to know something about mice. Okay. So here's just I gave this information in the problem. So this is just showing that down here, low in the picture, a mouse has that, this is where I got that 900 to 79 kilohertz. Okay. Then CDDA, digital audio, CDs, they sample at, so they take 44,100 samples per second. And then each sample is 2 bytes or 16 bits, and then they recorded from 2 different positions to be in stereo. And the samples is related to human hearing and Nyquist. So then we move over to Nyquist, and Nyquist's theorem states that the signal must be sampled at least twice as fast as the highest frequency component of the signal, or in this case, the highest frequency component of the signal that is can be perceived by the audience, in this case originally humans, and then in our case mice. So at least twice as fast as the highest frequency component of the signal to accurately reconstruct the waveform. So those are our components. So that if we go back to hearing here and find humans, which are in magenta, I guess, human goes up to 19 kilohertz in this picture. They often say 20. And this is more than twice that. So we'll say in our solving the problem, we'll just take the mice and we'll double it, but some people will go a little bit more and do, I don't know, maybe 2.2 to get a little bit, have a little bit of wiggle room to be a little bit more than just the bare minimum for Nyquist. But here we go. So it is the high frequency that we care about. So that is the 79, and I'll put in 0, 0, 0, 0. The 79,000 hertz is the sampling rate, and I'll throw in some units, samples per second, and maybe some parentheses. So I'm multiplying that. That's the highest frequency, and I'm going to multiply that by 2. I'll just use an x times a 2, and I'll say, I don't know, a la Nyquist. And that's just a 2, has got no units or something like that. And then I'm going to multiply it by, now I have to ask if I think that, 2 bytes is per sample is enough for mice. I'll just say it is. We can see here in terms of our units, the sample in the numerator of the sampling rate is canceling with the 2 bytes per sample. And so now we're left with bytes per second. And then where are we at? And then just another 2 for, and that's again, it's just a number, so no units of stereo. So sort of as an answer to this, as a fast answer to this question, we'll say we'll take the upper range of mice hearing, and multiply it by 2, a la Nyquist. Then we're going to turn it into data transmission rate. So we're going to say how many bits or bytes per sample. It didn't say I wanted the answer in bytes or bits, so I'm going to give the answer in bytes. But if they wanted the answer in bits, I would multiply by 8, of course. And then I take the highest frequency, I multiply it by 2 because of Nyquist. You might see some people do a little bit more than 2 to give themselves some wiggle room, but I'm going to say 2 is good enough for me. How many bits or bytes per sample, and then stereo, or maybe you want to do quadraphonic or something like that. But so long as you're sort of explaining what you're doing, um, and know and understand Nyquist, then sort of all these possibilities are sort of acceptable. So I would just take 79,000 and multiply it by 2 and multiply it by 2 and multiply it by 2, and my answer will be then in bytes per second. All right, that was it for this one. Thanks for your attention.